And I am here at one of the world's biggest electronics market with Makeresan, and we're going to check out some of the stuff that they're selling here. Okay, so at this market they have
Does it work? Yeah. All right. Yeah.
I guess this is just like this. Check, check, yeah. Test 1, 2. Yeah, okay, I'm gonna put up the volume a bit. Hello. Welcome. So we're going to get started in about 5 minutes' time. And we'll go tell the people downstairs to come up here as well. If we run out of space up here on the first floor, then we have additional space downstairs. And we're streaming the video from up here to a projector downstairs. So if it gets too hot or just too crowded up here, there's some more space downstairs. So in about 5 minutes, logistics-wise, there's a two bathrooms just out here on the first floor by the staircase, and there's another two bathrooms in the basement. There's a bit of beer in the kitchen if you want to stock up before we get started in a few minutes. There's some non-alcoholic there, and you feel free to take some water, and there's glasses in the cupboard.
I've got this great idea for a IoT device. Jewelry. Yes, it is. Very, very interesting. It can be made, it's not science fiction. But it's basically like something you can wear.
Oh, don't you look professional?
Yeah, don't I? It's this.
That's right. Oh, we're gonna do a few announcements first, just so
Okay,
like
so
there's
I
a
don't-
few things before you come on.
Yeah.
Actually, yeah, there's announcements too, so there's gonna be a little.
Are you speaking? Announcing. Announcing, okay. Speaking about artificial intelligence and fluffy stuff. Yeah. No, it makes a lot of sense. We do artificial intelligence.
Really cool stuff, right? I'm really cool and I'm cool.
Thank you.
I also organize IoT Week here in Stockholm. So we realized that IoT is just massive technology.
Hello and welcome. Cool. We have a good amount of space today. So welcome to Stockholm Hardware number 4. Today we'll be talking about hardware in general and sensors specifically. We've got 2 main speakers and 8 speakers for lightning talks. So there's a lot of very good content. The first 2 talks are going to be about 20 minutes each. So we're going to get started in about 5 minutes time. Okay, so we have a live stream, and that live stream is slightly delayed, and it's running on as a YouTube live stream. So if you want, it gets a little crowded up here, you can go downstairs and you can see the live stream from there. Of course, if you're not here, in fact, you may not be here right now and watching the live stream anyway. We'll also archive the videos and cut them up into smaller chunks and so on. Anyway, what I was saying was there is 2 main talks, each about 20 minutes, and then there's these 8 lightning talks, which is short, to the point, about 5 minutes. We're going to time keep pretty intensely, especially on the lightning talks, because we have so many. Cool. It would be great if somebody could volunteer to have a little look at this camcorder that's standing over here. It's not a lot of work. It's just kind of like keeping track of whether it's running and whether it's like actually pointing to the person who is on stage. Volunteers? Somebody? You get a good seat. You get to sit up here. Okay, you don't need to do anything super amazing. Awesome. You just need to like look into the camcorder eye occasionally. Woo! Not only do you get a good seat, you also get lots of applause. Great, yeah. Especially for the lightning talks, we may have people that's kind of walking back and forth, so that would be great if we could kind of keep track of that. Okay, Stockholm Hardware is about building a hardware community in Stockholm, and increasingly maybe also beyond Stockholm and in Sweden, but certainly with a strong emphasis on Stockholm. And we try to organize the content such that it caters for many different target groups. So beginners and experts, creatives, engineers, business people, everyone. We are 6 organizers. 6 organizers. I am one of those 6. And Ellen is downstairs. She's one of the organizers. And then we have an organizer that's sick, another organizer that's in New York, and so on and so on. These 6 organizers help bring together the content. So they're helping me out a lot. Here's the agenda. You've already had mingled beverages and light food. So now it's welcome. And we'll do a few community announcements, and then we'll get running on the content, the talks. Then we'll have a break, 15 minutes, then lightning talks, and then a wrap up. Anyone from Stockholm Makerspace to do Makerspace tours? Not today. Yes? That would be great. So in the past, during the break, if anyone's interested, they can get a short tour of Stockholm Makerspace, which is in the basement. Is that cool? Are you okay to do that? So if you're interested in that, go over to the guy with the hand in the air. Yep. So this guy, if you're interested, will give you a 10-minute tour of Stockholm Makerspace so that you're back here in time for the second half. Okay, this is the list of all the speakers. It's pretty impressive. We'll put it up on the website. You can get in touch with them afterwards as well. I already mentioned that we're doing live streaming, and we're looking to put together an archive of all the videos so that over time it can help us learn as a community. That was not me. Okay, logistics, food and drinks. There are as many wraps as there are downstairs. I think there are still a few left if you're more hungry in the break. There's some beer downstairs, and there's more beer in the fridge. The beer in the fridge opens up when it's break time, so please don't walk back and forth like it's a bar while we're going on. But in the break, feel free to take what you want. As I mentioned, the main thing is up here, and we have a stream downstairs. Bathrooms. On this floor, there's 2 by the staircase, and then there's 2 more in the basement. An outdated slide. I'll show you at the end of the event. I'll put up something on the screen with the next date. So we already have the date confirmed for June, and I'm pretty sure it's Tuesday the 14th. I'll put it back on the screen a little later when I get my slide in order. Sponsors and partners. The place you're at now is Things Stockholm. It's a co-working space for startups and to build community around hardware and IoT. They helped us get started. They're providing the space and the food and beverages, so thanks to them. Anyone from Things now? All right, perfect. Stand up. Hello, 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 hello. Thank you. Yep. Very cool. And I think 2 of the co-organizers for Stockholm Hardware is actually sitting here, located here. We're looking for more sponsors to get the event to get even better. And I'm happy to announce that we did actually just get a sponsorship from Internet Funding. I think it's part of the IIS.se organization. So they are supporting the internet industry in general, and also a sponsorship from Wirecast that helps us do the live streaming. So that's very awesome. I was going to ask you, for those of you that have your smartphones with you, I think it would be great if you don't mind helping us saying thanks to the sponsors, and also just spreading the word in the community. So the way that we run these events is because people in the community knows about it. So if you don't mind, could you take out your phone, take a picture of this thing, and just share it on Stockholm Hardware. So just share it on Facebook or Twitter or Instagram or whatever you're into, and use the Stockholm Hardware hashtag. That would be great. You may have noticed that you didn't pay to come to the event today, and I think that's really awesome. I hope we can keep it that way. And to keep these events going for free, we need these sponsors to believe that people care about the events. So when you put a post on social media, it tells our sponsors that you care about the event. So thanks a lot for that. There'll be more opportunities to take more photos as you go, of course. The speakers will come up, and they may even have something very exciting to show you. But Stockholm Hardware hashtag would be great if you can use that across the different things that you're using. Okay. So we try to encourage anyone in the community to come up and do short 1-minute announcements for whatever you're interested in or whatever is going on. So we got a few of those, and if you have something you'd like to talk about up to a minute, then feel free to come up and just stay in line and jump up. I wanted to first just mention Lilu. Hannah from Lilu is not here today, I think, but she was here presenting last time. And they managed to extend their Indiegogo campaign, and they're very, very close to being funded. How many was here last time? So about a month ago? Okay, interesting. So it was maybe 10%, so there's a lot of new people. So Hannah, one of the co-founders of Lilu, talked about this toy that they're doing on, they're funding on Indiegogo. And they're obviously almost at their goal. So if you have kids in the 2 to 5 year old range, maybe, take a look at it and see if you want to support them. They're jointly based in Helsinki and in Stockholm. Okay, another community announcement. Laura, for our Stockholm Startup Weekend. Welcome, Laura.
Hey. Oh, a lot of people. Good to see you all. Suna loves a Startup Weekend. He was part of it. So we are having a new event coming up. Has anyone been part of Startup Weekend? Oh, there is some people. Oh, helping hand. Good. So we are having next event in June 10-12. It's 54 hours hackathon, no talk, only action. So basically, if you want to pitch an idea and see how it is to start a company in 54 hours, just drop by. If you have any questions, there is more information online, or I will be around, so you can just pop by and ask me. Cool.
Very nice. Thank you, Laura. And I think, Tatjana, this is you?
Yeah, exactly. First time ever, I'm not presenting or introducing Startup Weekend, but you might know me or my face because of Startup Weekend that we organized with Lara and a bunch of amazing guys. First, actually, I would like to know whether my information is relevant. Is anyone here, I hope, related to hardware or IoT? Awesome. So anyway, you might know that Stockholm would like to become the smartest city ever on Earth, maybe on Mars as well, or Moon, by 2040. Have you heard about that? If you haven't, here is a piece of information for you. In June, on the 22nd of June, we organized a Spring Hack together with Stockholm Stad, or Stockholm City. They first time ever, they're gonna give you, or us, their APIs to immense information, to immense amount of data. And they have real cases, and they're looking for real solutions. So, on the 22nd of June, you are all invited for a hackathon, half-a-day hackathon, totally free. And we are looking for teams of people who would like to challenge, who would like to create something cool, and who would like to win 100,000 crowns. So, welcome.
Good stuff. Does anyone want to talk about Stockholm Mini Maker Fair? Anyone particularly involved? Nope. So it's happening. I was involved with it last year, but not this year. And it is just around the corner. Is it this weekend? Yeah. Okay, cool. Anyone going? Yeah, all right. There's like 10 people or so. Okay. That was all we had for community announcement. Any last minute community announcement? Somebody who wants to?
I forgot. If you're interested and want more information, please contact me.
Come talk to Tatjana if you want to know more about the hackathon with Stockholm Stad. Okay. So then now it's time for Alexander from ImagineMob to talk about sensors and artificial intelligence. Let's give him a hand.
Where did you put my slides, Suna?
Sorry. Eternal problem with the slides.
Can you guys hear me in the back? Awesome.
There we go.
And in the front. Cool.
Nope. Here it is. This one, right?
Yeah. Does it show?
No. Like this.
Oh, awesome. Okay, so my name is Alex, and I am the CTO of ImagineMob. And at ImagineMob, we understand the motion of things and people. So what does that mean? It means that we make a software that using sensors, motion sensors like accelerometers, gyroscope, compasses, you can show motions from these sensors to our software and you can label it. And that could be my walk, for example, if I had a sensor here, or a gesture with my hand. And if I repeat this over and over again, our system will be able to recognize and match that motion in the future and tell you what actually happened. So essentially what we do is that we connect sensors to artificial intelligence. And I'm going to tell you why this is such a good idea and why everybody should be doing that, because sensors are quite dumb. So anyone here who has worked with sensors? Maybe writing some software, building some hardware? Quite, yeah, a lot of guys doing that. That's cool. Then you know that sensors, they generate a lot of data. So if you have a standard MEMS accelerometer, usually it tells you its interpretation of the world 10, 50, 100 times each second. And that adds up to a lot of data. Not only that, that data usually contains a lot of noise. So if I'm trying to recognize my walk, and I have a sensor on my wrist, I might walk ever so slightly different. I might bang my wrist onto my leg, creating a lot of noise. Not only that, sensors are dumb. They have no memory, and they have no interpretation of what is happening over time. They just tell you what it is seeing in that fraction of a second. So wouldn't it be good if sensors generated a lot less data? And that data had much less noise in it. And what if the sensors could understand what is happening to them? If we had this, that would mean that we don't have to transmit what the sensor is seeing all the time. And we could save a lot of battery. We could live for a year on the same battery that we're using today. Not only that, if we can make decisions, we can log things, we can remember what is happening even if we don't have a connection currently. And if a link goes down, we can still send an alarm if something important happens. So let's do that. Let's make sensor autonomous. So how do we do that? We connect sensors with artificial intelligence. And what is artificial intelligence? Artificial intelligence is just a way of taking a crazy amount of input, like the input you get from a sensor, and turning it into decisions. And the way you do that is that you look at your crazy amount of input and you look for interesting features. You extract features from your data in order to compress it into something smaller. But then you still get, over time, you have these chains of features happening. So you want to get this even more compact. You want to reduce the dimensionality into something that you can recognize. You want to turn these features into a pattern, or you want to map them into a space that you can confine and label. So for example, if I'm walking, I want the output from my sensor to get mapped into the space that I have labeled walking. And then when I see walking, I can log that. Or maybe my grandma is falling over, and I want to send an alarm because we mapped into the falling over space. So yeah, in order to do this, we start with extracting features. And the way we do this is that we look at what the accelerometer gives us, and it gives us an x, y, z value, like the 3 dimensions in space, every fraction of a second. And if something interesting happens in the x space, then we put a feature here on the x line. If something interesting happens in the y dimension, we put a feature in the y line. And the same goes for z. And you get these chains of features. So we're not done there. We still need to map these features into labels telling us what is happening. And a standard way to do this, or a really popular way to do this today, is by using something called an artificial neural network. And the problem with an artificial neural network, as you can see, is that it is really complex. So it can't run on a low-power device next to a sensor. It just costs too much to go from your input to your output. And what is even worse is when you want to go the other way. So the way you teach this network is that you show it a lot of example data. So if I'm teaching this my walk, I'm presenting this network sensor output of me walking over and over and over again. And then I look at my output and I see, okay, does the output say walk? Okay, if it does, fine. I'll let the network be because it obviously knows what it's doing. But if it doesn't, if there's something wrong here somewhere in the output, I tune that part. I twist it ever so slightly into the direction that it should be. But when I do that, that propagates through all the active connections in the network, changing everything here. So I have to tune it very carefully because otherwise it will forget what it learned previously. So if I'm going to teach this my walk, I might have to walk 1,000 kilometers. And that's pretty painful. So what should we do? We should listen to the sensors instead, and that's what we do at ImagiMob. So if we go back to, shit. That was weird. Obviously, I shouldn't stand too close to that one. If we go back to these features, we think of these features as strums. Is that how you say? Strumming a string on a guitar. So if I get a feature in the X dimension, I play a note on the guitar. And it might sound like bo. And then I get a feature in the Y, and it might sound like ba. And then I get X and Y simultaneously, and it might go ba wa 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 wa. But maybe I want to draw a circle in space, and that would turn into an even more complex sound. It might sound something like ba wa 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 wa. And then I do another circle. It's pretty similar, but not exactly the same, but it sounds similar. Ba wa 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 wa. And as I do this over and over again, these circles will map into the sound of circles. And I can build up a statistical model telling me, okay, which parts of the sound varies? How do I confine this space? So now I can label that space. So I've reached the goal because this can be executed in a very low power device on a microprocessor right next to a sensor. And so what I want you guys to take away from this talk is that sensors and AI is a really good match. Because without AI, sensors consume a lot of electricity and they're not autonomous. They have to depend on something on the outside. So if you work with sensors, go and take some AI courses. Build cool things, and if you fail, call us. And if you succeed, call us, because then we want to hire you. Yeah, that was it. Any questions? Come on. Okay, you there. No, you.
Paid my full attention, but I kind of missed the jump from neural net to sound.
Yeah. Okay.
Could you just repeat the question before you answer?
He paid full attention, but he missed the jump from neural network into sound.
And how does to connect with sensors? Do sensors play the sound, or you present the data as a sound, and then you process the sound, and that is cheap.
Okay, yeah. So I'm speaking in analogies here because I don't want to give away all of the secrets that we're doing for obvious reasons. But so it's so it's an analogy. So we have what we call a harmonic resonance model, and it is not a sound that we are processing. We generate a pattern from these features, but we think of the guitar is really a good analogy because we let the features live for a while, like a sound. Bo. And then we have like a microphone that are tuned to listen to certain sounds and understand the composite of a more complex sound. I don't know if you...
Let's do the demo. We'll try some stuff.
Yeah? Okay, so I'm going to show you a little demo movie which is showing... It will show you our software in action. Can you guys see here? I'm gonna pause this. So what you see up here is features going into the system, like someone playing a guitar. And at the start of this movie, the system doesn't know anything about what it is seeing. So what I've done is that I've created 3 labels. I've called them house, heart, and walk. And then I'm gonna show my system these 3 things, and whenever I'm doing it, I'm gonna say to the system, learn, learn, learn. And eventually you'll see that it doesn't get it in the beginning, but then it does. And when it gets it, it will pop up some green text over here. It's telling you what it found. So here I am, I'm gonna start learning it, what a house looks like when I draw it into there. And this is kind of stupid because I'm talking in the video. Okay, so the system doesn't understand it yet, but it's starting to build a pattern out of what it is seeing. And now it starts to get it. And it will only get better and better. And now it's not learning anymore, it's just matching. There we go.
Question?
Yep.
What if you vary the angle of the roof? Would it still get it?
Maybe. Okay, I'm gonna. Yeah.
If you vary the angle
If
more than
so,
5 feet?
so okay. The question is, what if I vary the angle of the roof a couple of degrees,
No, more like
15 degrees? Would it still get the house? The question or the answer is maybe. It depends on how you can set the accuracy of the algorithms, but possibly you would have to draw some more houses with a slightly different angle, and then you get another pattern for that. So you can build up a database of patterns, and you can also put a composite of patterns together to understand more complex things. Yeah?
Have you applied this technique to any other type of sensors?
The question is, have we applied this technique to any other kinds of sensors? Apart from MEMS sensors. We have tried it a little bit with sound. And we've been able to see things like drums and piano sounds, recognize that in sound. And my colleague over there, Tony, did that experiment. Yeah. Sorry? Yeah, you, yep. I'm trying to look, yeah, you. You.
But have you made a speech recognition
No, we haven't tried that. So the question was, have we tried this on speech, to do speech recognition? And the answer is no, we haven't. We're really focused on motions. And we think that that area is big enough, but it is possible in the future that we might look into that. You over there?
How do you envision this is going to be used? Who's going to buy it from you guys, or are you going to develop? What are you going to do with it?
Okay, so how do we envision this being used? How are we gonna? Yeah, who's gonna buy this? So we have two commercial projects right now. So this tech is going into a dog tracker called Tracy Tracker, and then you can not only position your dog, but you can actually see what it's been doing throughout the day. So if your dog is drinking, if your dog is sleeping, walking, playing, you'll be able to see that in your app. And we're doing the same thing for cats for another company called Moggy. But we have a lot of other interesting projects with other companies that I can't talk about. But we're thinking industry, health applications as well. Yep.
What kind of hardware do you need? You talked about going into computing resources.
Yeah.
That was the main force for this.
Yeah.
What do you need to run a software like that?
So the question is, what kind of hardware do we need to run this? What we need is standard MEMS sensor, like an accelerometer, and then we are using an ARM Cortex M0 core as of now, so really low power hardware, and we're not using the entire capacity of the ARM Cortex. Huh?
How many percent of the capacity of the ARM Cortex are you using?
Very good question, Tony. Well, roughly 10%, I would say. And he usually says a little bit lower, but I'm careful. It all depends on the rate of the accelerometer, of course, and how many patterns you have. And so I don't know. I still have some left of the video, if you guys want to see. Yeah. Okay, so now am I still doing the houses? Doing the houses forever. Okay, now I'm teaching it the heart. And I think it starts getting it. Yeah.
What happens if you try and draw a camel?
If I try to draw, yeah, hopefully it will not recognize it, but it depends. Yeah, so enough with gestures. Now I'm gonna put the sensor in my pocket and start walking around with it. And you can note that it still knows the previous gestures that I taught it, but it doesn't match on those. So it's pretty robust. And now it starts getting my walk, and it only gets better and better.
What if you start walking in a heart shape? Will it get really confusing?
Yes. So the question is, if I walk in a heart shape, will it get confused?
You can teach it a heart-shaped walk.
It can actually, you can teach it the difference between your walk and my walk, for example.
So something for Monty Python.
Yeah. Totally.
use a gyro and accelerometer for that?
So the question is, did we use only a gyro and an accelerometer for this demo? No, just an accelerometer. So we can do better with both, and we can do better if we do sensor fusion, getting rid of gravity, but it's not needed for all the applications. And now my time is out, I think. Thank you.
Good job. Thanks a lot.
Thank you, Sune.
Are you maybe gonna hand over that mic to Claes? Yeah. Okay. Great. So next up we have. Let me see what I got for us here. Okay.
I need 3 hands.
Yeah.
Yeah. Okay, hold on. Does it work like this?
Yeah, that looks perfect.
Thank you.
Here we go. Okay, so welcome Claes Jacobsen, co-founder and CTO of Botanist.
Yeah. Okay, so how much time do I have?
Do you want to maybe just find it while? Do you know how to find it?
No. Okay, so it wasn't
in there
on.
somewhere. Cool. Yeah, I'll put your timer on 20 minutes if that's.
Yeah, that's
cool.
fine.
Great. So Claes is going to do his talk about Botanist, which is some kind of hardware for something with plants. Is that right?
It is.
That is right. But you're going to know a lot more about it in
And
about
it's-
20 minutes.
And it's up to you what kind of plants you want to grow. If it's funny plants or
Funny plant.
vegetables.
And then after that, we're going to do a break. And in the break, you can refuel and restock on beverages. And then we'll go through the 8 lightning talks afterwards.
Is there some kind of...
There's no Klegger today,
Okay, no Klegger.
unfortunately.
That's fine.
Take it away, Claes.
Yeah, I only have 18 slides, so I'll run this fast. Should we pass around some hardware? Yeah, I brought some prototypes. And so, Botanist, has anyone heard of us? Is anyone into gardening? Yes. Good, then you like this. Is anyone into growing stuff that the government probably don't want you to grow? Good. Yeah. And then you might want this too. But don't say that to the government. So my name is Claes Jakobsson. I'm the basically head honcho. So I do most of the stuff except the hardware because I really suck at electrical engineering. So do not ask me any hard questions because I will not be able to answer them. I've been doing mostly financial systems my whole life, which is extremely boring. So doing hardware every day puts a smile on my face. When you come in the morning and you say, oh, I have 128 bytes of RAM in this device. This is going to be so much fun today. So let's see some pictures. Oh, that's our prototype of the wireless sensor. In case you're wondering how big these are, they're about 3.5 centimeters square, which is way too big. And the new one will be about 2.8 centimeters square, including battery, solar cell, radio, and all the sensors. So tiny stuff, but can be made even smaller. There's a picture of the wired one. So what we do is we build like a hardware and software platform for growing stuff, mostly plants, but you can, in theory, it's a fairly generalized hardware platform that just happens to be used for gardening. But if you want to run other sensors on it, feel free to do it, because we will be open sourcing most of the stuff, and all the hardware will be fairly open, so you can build your own sensors and actors if you want to do that as well, and you can run virtual devices if you want to connect to your PLC or your irrigation controller or whatever. Let's see some more screenshots, action shots. That's some of my plants. Don't complain because they look really sad. So let's see, should we skip down? Yeah, so that's the platform. We designed it to be really affordable. which is extremely difficult to do because apparently stuff costs way too more than you want it to cost. It has to be extremely simple because our main audience group is like 40, 50-year-old women who might not be that tech savvy. So they have to be able to use it. And being an open source guy, I of course wanted everything to be as open as possible. We also want, it must work offline. So it's, in theory, it's not an Internet of Things product because we don't use IP, and we do have a cloud service, but we prefer if you run it locally, because the cloud service is more or less just a read-only mirror of the data that you have at home. I've been doing this way too long, for 3 years now, so it's been more of a research project, learning all I can about gardening and how you build sensors cheaply that works in a garden environment. And we're trying to commercialize it now. So if you have some money to throw at me, please do so. I will gladly take it. So I could talk a lot of botanist about the architecture stuff, but that is kind of boring since this is a hardware meetup, specifically about sensors. So let's talk about the sensor. The standard sensor, where is it? Somewhere there, right? So that's like a fifth generation sensor. It is the standard sensor that we build is mainly for soil-based cultivation. So there's other ways to grow plants, for example, hydroponics, where you grow it in water. There's an extension of hydroponics called aquaponics, where you have living fish that poo, and then they turn the poo into nutrients, and then the plants get happy. And then there's also aeroponics, where you grow it in air, basically, with like a moist environment. But our sensor is only for soil-based cultivation, and with soil we mean like normal plant soil, but it also works in coconut fiber mixtures, and it works in like sand. It will not work for your orchids, because those you normally grow in what's called bark in Swedish. We have it in a wireless version and a wired version. Those ones that I'm passing around is the wired ones. They're much cheaper than the wireless one, because we can eliminate the battery and much of the other stuff. So they're mainly for if you have a greenhouse, you have an irrigation, and you have all other kinds of stuff. You're normally fine with having wired sensors. And then you can get away with around between 120 and 150 Swedish kronor for each sensor, which is kind of fine. It measures soil moisture, it measures ambient light, and it measures temperature in both the air and in the soil, because you want to know both of them. We had some challenges during the development. People said, oh, I don't want this to take focus from my plants. So it has to be really, really tiny, which I think we've done. Some of our 2 or 3 competitors, which exist, they're like big and ugly, if you ask me. And you don't want that, you want a small one. It has to survive in a fairly harsh environment, because you don't want to take out the sensor when you water. And if it gets too cold, well, you don't want to have to take them in. In a greenhouse, it's usually fairly humid, so it has to survive in that. And there's some other problems with mechanical, tension when you put them down in the soil as well. It had to be really, really cheap to build, so we had to minimize the BOM, and we had to make it single-sided to lower the manufacturing costs and all kinds of stuff. Too much work went into that. So let's see, that's a picture of oh, it looks crap. That's a picture of like the 5th generation sensor. And we have 2 temp sensors, and we have a microcontroller, which happens to be an 80-tiny. But the new ones doesn't have 80-tinys. We switched to ARM. You have this is the soil moisture sensing part. We have, a nice feature, we can daisy chain our sensors. So you can plug in one sensor to another in a daisy chain, and it works. So you don't have this ugly mesh network. We have a LED that we also use as a light sensor. And this one has a voltage reference, but that one is gone because it's not needed any longer. So that's basically the sensor. So how many of you have ever built a soil moisture probe? Good. So how did you build it? Resistance or capacitive?
Resistant.
Okay. Did it work good?
Yeah. I think that was only meant.
So basically, when you measure soil moisture, there's two basic versions to doing it. Either you measure the resistance of the soil, or you measure the capacitance of the surrounding medium. Building a resistance meter is extremely simple. You just like pass a current and then you measure the voltage on the other side, but it works really crappy, mostly. It can detect, oh, is there water, is there no water, is there a little bit of water? But then you start adding like nutrients and salts and changing the temperature and changing the soil medium, and then your values go poof. So then you turn into capacitance sensor, where you basically use the medium as a capacitor that you charge really, really, really fast. And the faster you charge it, the less noise it becomes. It utilizes the fact that water has a much bigger dielectric constant than air or soil. I think air is around 1, vacuum is 1, water at 20 degrees is 80, and soil is about 4. So you can use that fact to calculate the more accurate soil moisture. I can't tell you how accurate it is, because we haven't really measured that, but it is fairly accurate during our test. I would say somewhere around in the region of plus minus 5% or less accurate. It happened to be that the response from the sensor is extremely linear, which is very nice. So you don't have to do any complex mathematics to convert it to a percentage. You need to know the temperature of the water surrounding the soil, because it changes the electric constant. When it gets really warm, it gets really low, but normally then your plants will die of other reasons. So the major problems we had is that an oscillator is an expensive part. It turned out it was about 25% of our BOM cost, which is $0.75 US, so you can figure out how much the hardware and that stuff costs really. The initial version used an analog comparator for doing for making the square wave that we put into the capacitor, and then you get you measure the time it takes for it to discharge, and then you put that in the comparator, and you get some PWM signal out that you convert through a low-pass filter to a voltage, something like that. I don't know exactly how it works. But that was a really expensive component, but apparently you can use an XOR for it, which was really nice, because those are dead cheap. So, small trick. Then, of course, there's the problem with water surrounding the components. So you get a short if you don't do any conformant coating, which actually also turned out to be quite expensive. And there's a funny thing, because some of the PCB manufacturers, they said, oh, this PCB is going to work like a sponge and soak up water, and you're going to get shorts within the PCB, because we use 4-layer PCBs, since we have no contact with the medium that we measure. But I've had PCBs in water for several months, and nothing has happened. So I wonder if this is just a happy coincidence that they are very well glued or not. But I guess we have to do some kind of coating to protect them, since they have to survive for 3 years, and then the warranty is out, as I see it. You also need some kind of mechanical protection. So if you see the one with the box, there's a small plastic over the actual components that go under the in the soil, because there are rocks and stuff in the soil that can otherwise tear off the components, and then it will not work, apparently. Yes, that has happened. So ambient light, we did a lot of tests for how to measure lightning. So I think I had a rig up with 20 different kind of photodiodes and phototransistors and ambient light sensors, ranging from really, really cheap to really, really expensive. And some of them were good, but then we figured out, well, I didn't do anything. My companion who does the electronics, he said, oh, you can use a LED as a sensor. If you light a laser on a if you light a red laser on a red diode, it will give you some electricity on the outside. So we did that and we measured the voltage and it worked fairly good. But then apparently there's a better way to do it, and that's you like charge the LED, but you don't have a ground, and then you put the ground as an output, so it sucks out the energy somehow, and then you measure how long it takes for it to go down to 0. And from that you can figure out if it's dark or if it's light or cloudy or overcast. And it works fairly okay, but it's... Sorry? Oh, if you have any questions, just raise your hand. It is not a lux meter. It's very crude, but it works accurately good for a consumer-grade electronics part for that kind of money, so to say. There are some problems. We don't do any continuous sampling. So if it's very changing clouds, it might be unhappy that it's every time it samples, it happened to be sun, but 75% of the time it's actually cloud. So that we have to solve. I have some ideas how to do it. But since we envision that you normally have more of these sensors running, we can actually take the data and we can group them and use sensor data from other sensors to figure out what to do. So it's, in theory, it's a problem, but in practice, it will probably not be a problem, which is kind of nice. Then, of course, plants, they have leaves, and leaves can cover the sensor. So it is not facing upwards, it's actually facing to either side, because that is normally not where you have leaves. So extremely simple design. The temp we measure using Texas Instrument sensors. Here too we build a lot of rigs with practically every temp sensor there is on the market and tried which one gives us the best price performance. And it happened to be that the Texas Instruments LMT87 was a good match, which we will of course switch to another one now, because why not? It has a typical accuracy of plus minus 0.0 degrees Celsius, which is typical. In worst case, it's like plus minus 3 degrees, but you can figure that out during calibration of your sensors and just don't chip them. It has a very wide temperature span from minus 50 to 150 degrees, far more than any of your plants will ever survive. It comes in a really small package and they're very low price. Thermistors exist. We have the MPC 9700 from Microchip. That could work as well. But eventually we settled for this, and there's a good reason why. And then of course we have two. So sense accuracy, how much time do I have? 4 minutes? Oh, that's fine. So they say you get 0.3 degrees accurate sensor. But then there's a lot of stuff in the way transforming that 0.3 to something that we can actually read. And if you do a bit of the maths, they tell you it's 13.6 millivolts for each degree that output that you get. And using a 12-bit ADC at 3.3 volt, which we normally do, that would give us about 0.8 millivolts per step, or our ADC would be accurate to 0.05 degrees. And add that with 0.0 degrees, it works. But if we use a 10-bit ADC, it turns out, well, there's 3.2 millivolts per step, which is roughly 0.23 degrees. And then you add that, and then you suddenly, oh, you have 0.5 degrees accuracy. And then, of course, you also have that you need to know the voltage in order to get an accurate calculation. And the built-in voltage reference in the MCU that we used was really crappy. So it had 10% accuracy. So we had to put in an external voltage reference, which gave us 1% accuracy. So this is actually not what we're giving you. We're saying like plus minus 1 degrees just to be safe. But that is fine, because that is, it's okay for a greenhouse or for your balcony. It's not a scientific instrument. So what are we doing now? Recent changes that are not visible on that, we're switching to ARM all across the line. So Atmel released their, they have this D21, which is used, I think, in one of the latest Arduinos. They took that and they made a much smaller version called the D09, which is basically the same core but less flash and less ROM, which is still like 20 times more than we actually need, but it's as little as we can get, and they're dirt cheap. They're like 4 Swedish crowns each in volume, which is nice. They have a much better ADC. They have a much better voltage reference. They're slightly smaller, so they're 4 times 4 millimeters, and that one is 5 times 5, so we save a bit of PCB space. And the nice thing is, you can actually, they run at 8 megahertz on the internal RC oscillator, and we can use that through the phase lock loop and actually get a 48 megahertz clock out from the chip. And then we can use that clock out and remove the oscillator that was really costly and just use the clock out from the MCU instead. And of course, we get a bit of more noise on the moisture sensor, but that's fine if we save 6 Swedish kronor. We also have a bit of a problem with voltage drop. Since you can daisy chain these, the last sensor in the chain will not get 3.3 volt. It will get, like, if you have 7 or 8 and you have 1 meter cable, I think we measured about 2.8. And then suddenly, some of the temperature sensors that we used, well, they stopped working. Fortunately, why we choose the LMT87 is that they also produce a lot of versions of it with different sensor gains depending on your source voltage, which is nice. Then we could also save 1 Swedish krona per sensor by switching the LED to a cheaper one, which is nice. And it might sound ridiculous to like save 1 Swedish krona here and there, but every krona that you save ends up being 5, more or less, on the end price. And if you're going to churn out a couple of millions of these, then it's a lot of money that you can spend doing more fun things. So how does it look? This is the BOM cost estimate, roughly, where the costs are. I thought someone might be interested. A jack is really expensive, especially if you need something that is waterproof, which you need if you're going to do automatic coating. Otherwise, it would be bad. And that's, you see, like 30% of our cost is the jack. And finding a waterproof 3.5 millimeter TRS jack was harder than I thought. There are apparently not that many manufacturers. Fortunately, there's always Shenzhen, and they have everything. The PCB is, oh, can I go on, or? Yeah, good. The PCB is a fairly big cost as well. I would have guessed the MCU was the biggest cost, but not. The temp sensors are fairly costly. The FETs are part of the daisy chain, so that is not something for the sensor. But this is roughly how the cost estimate is on the BOM cost. So what if you want to use these sensors? You can't buy them now, but we will happily sell them to you. Even if you don't want the rest of the system, you just want the sensors to play with, you will be able to buy them. We talk I2C over a very simple protocol that we will, of course, open up, and with also all the electrical specifications that you need, so you can use it with a Raspberry or something. Don't use the Raspberry, it's no crap. And the problem is you get like raw data from them, so you need to convert that to something. But we'll give you all the formulas for converting the raw data to something reasonable. And then how reasonable, it depends on how much you want to implement. You need a standard TRS jack on the other side, or you build an adapter. It's not that difficult. So let's have a little, does this show? This is just a, no? How do you play this? Oh, that. So this is really fast forward. So here we just show how the soil moisture sensor work, and it samples like a volume of around surrounding the sensor, which is why it works to put it in a bit into water glass. And that's fast forward. That's my hot air solder. It's not going to melt yet. But that it got a bit hot for my hand, so I had to stop it. Oh, and then I skipped the light sensor. Or did you see that? Oh, it was really fast. Okay, thank you. Any questions? And as usual, I'm terrible at holding times.
Let's take a few questions.
Yeah.
You mentioned soil types, or a normal soil.
Yeah.
Do you calibrate with a specific soil or soils?
We will calibrate with. Sorry. The question was, what's our definition of a normal soil? And we will calibrate it depending on the soil. Our normal soil is the stuff you buy at ICA. Basically, that's the definition of normal soil. But you will be able, in our system, you will be able to select what kind of soil you have, and we will have different properties for it. So we will adjust the values. But the sensors themselves are extremely stupid. They don't know anything. They just give us the raw values, and then we do all the processing on the controller. They do contain calibration data when we calibrate them, so it doesn't. So the calibration data for the temp sensor and stuff is stored in the sensor, but you can read that out as well. Yeah. Was that answer to your question?
I just wondered if you're outside of Sweden and you don't go to ICA and you've got.
Oh, you go to Tesco and then you pick up there. So.
I mean, not Tesco, the soil types can vary so much depending on the plant. So.
Yeah, but it doesn't affect that much. Soil is basically still soil, and the.
Well, there's a big difference between clay and hot soil.
Yeah, but clay is not the normal kind of soil that you put in your plants. Clay soil you normally use when you are a farmer and you use it on the fields. But no, this is not designed for that kind of use. So it's designed for greenhouse where you have normal cultivation soil, which is the kind you pick up at ICA and stuff. But we will of course be able, if you have a clay soil sample, we will be happy to adjust for that as well. Yeah. Yes.
I think it's cool what you've done. I think the cost reductions and stuff is great. My question is, did you really need to do all of the cost reductions now? Couldn't people afford 50 krona or 100 krona?
Actually, the question was the cost reduction to do now? And the answer is yes, because we showed this at Garden Fair last year, at the Hemovilla Fair, and we spoke to a lot of people, and the price point is fairly set. So people are not willing to pay more than like 150 Swedish for a sensor, for a wired one, and they're not willing to pay more than 350 for a wireless sensor. If you need many, of course, there's the Parrot Flower Power, which sells for 600, but you normally just you buy one of those and have in your like favorite plant indoors. But if you want multiple sensors, which is what our system is designed for, then the magic number is around 150 for wired ones and 350 for wireless ones. So yeah, we had to turn every single crowd around. Yes.
The capacitive measurements, could you measure soil salinity, salt in the soil?
The question is, can you measure the soil salinity and stuff? pH and stuff? No. They say you can do it using measuring the electric conductivity, which is the resistance based, but it doesn't really work really well because there's so many factors that affect it. So it's more or less qualified guesswork. If you want to buy a professional grade pH meter, they are really expensive, and they have some kind of porous medium that ions walk through, and yeah, then you're away from the consumer grade hardware stuff. Sorry?
Most of them don't last that long.
No, and right, and they cost the cheaper ones are like 500 Swedish, I think, and then they go up and up and up depending on. Yeah, and a lot of the cost is actually the calibration of the pH sensor meeting. So it has to be recalibrated every once in a while, and you have to do it with distilled water and stuff. Yeah. Let's see. Yes, over there in blue.
Is there any foreseeable way to detect diseases or insects using
Um, okay, so the question is, can you detect diseases or stuff like that using moisture sensor? The answer is no, but there are other ways to do it. So if you take a normal camera, so the simple way, if you take a normal camera and then you remove the air filter, and then you film your plant, and then you run it through an algorithm, I think it's called the NVI or NDVI or something, which is basically how NASA takes a look on the Earth. They have a camera in space looking. And from that you can determine whether the plant is healthy or if it needs some kind of nutrients or if it has animals, pesticides on it. But yeah, we're looking at that as well.
Can you use UV light as well?
Probably not, no. Was that answer enough? Okay, good.
What's the battery lifetime?
The battery lifetime for the wireless sensor, that is unknown. Mostly because we haven't decided what kind of battery it is. But the wireless one will have a small solar cell that will recharge the battery. So it will probably not be a problem. The wireless ones themselves, we use a 2.4 gigahertz radio on using 802.15.4 networking radio, so a small protocol about that. We spend most of our time in sleep mode, where we draw basically nothing. The radio itself that we use an Atmel R21, which is the ARM core combined with their RF233 radio. It draws about 15 milliamps in active mode, which is not much. But since we're only alive like 1,000% of every second, it has very low power usage. And we do automatic meshing and we do self-healing. So the range is about 50 meters in free line of sight and about 10 meters indoors through normal stud walls. Oh, so I ran over 10 minutes. I hope it's okay. Right. Which is, but it's not on all the time. Yeah. So should we end there?
Yeah.
Okay.
Good job.
So apparently I have to end. Thank you. If you have any more questions, just grab me in the break and I will happily answer them.
Cool, great. Just wanted to mention, just wanted to confirm the date of the next meetup. we have not decided on the topic, which we normally do, but we do know the date. It will be the 14th of June, which is a Tuesday. So it is a bit more than a month away. Feel free to reach out to me or any of the other organizers with suggestions for lightning talks or even topics for the main talks. We have been tentatively chatting about open source and open hardware as a topic. So if you're passionate about that, get in touch. If you have other ideas, then let us know. Cool, so that was the date. And oh yeah. Could you please come back with was it 3 sensors? Please ship the sensors back up to the stage. When we come back, this is the lineup for the lightning talks, and there's a 15-minute break. See you in a bit. So if you're a speaker for lightning talks, maybe come up to take one of the front row seats, and make sure to submit your presentation to the the information that we sent out earlier. But if you're up for a lightning talk, come up to the front row.
a second. Hello? Yeah? You? Yeah, very good. Good?
So let me just, I'll just scoot you around so you can see the crowd here.
Cool. Nice.
We're just on a break. So I just wanted to do the Skype check before we come back.
How's it going?
Let me. Can you still hear me now?
Yeah?
Okay, great. Okay, great. Yeah. So I'm gonna look at you up on the main screen. So you're not gonna be. You're gonna be up there for us. So I'm gonna look at the wrong place when I speak to you. Okay, great. So I'll call you back in like 20 minutes.
Okay.
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 Bye.
Bye-bye.
Okay. It is time for the second half, which may in fact be more like the third. But let's get seated again, and then we've got a number of really awesome lightning talks. I'll show you. Looks like this. And I think I don't think we are running downstairs anymore. It's a little hot up here. Thank you. Is that a battery or a coin? I found it. So for you. Was it the 1 sec from the bomb costs? Very symbolic. Cool. So this last part is probably about, it's probably max an hour. We have 8 lightning talks, and we're pushing for all of them to be 5 minutes. And I'll run the timer, and we'll try to be pretty strict on it. Cool. First thing we're going to do is a little bit of Skype. We're going to dial in David, who is very active in the hardware scene in London. So let's see if we can make that work out. Show of hands, how many people think we're successfully going to dial in David and make this all work out? All right, no, but yeah, okay. Very, very optimistic. 2/3. We have done it before. That is true. Go. Here we go.
Hello.
David.
Here we are.
Okay, very good. All right.
Hello,
Say hello to David. Cool. David, so we're in the middle of our fourth Stockholm hardware meetup. And as we spoke about the other day, we were talking both generally about hardware and specifically about sensors. And you've been doing hardware in London for a while. I was thinking you could just tell us a bit about what you're doing in London and what's going on in the hardware community over there.
Yeah. First of all, thank you for inviting me. And yeah, so basically, we started in 2013 a meetup like you guys. And at the time, there wasn't much going on in London in the hardware community. There was an IoT meetup, very big. But there wasn't anything specifically for hardware startups. And since we started with, we covered specifically everything around the business of building hardware companies. So inviting influencers, incubators, manufacturers, etc., etc. So I'm more knowledgeable, let's say, on the sort of hardware business rather than the hardware maker hobbyist thing. So I'm gonna maybe talk a bit about London and about this aspect of London. So as many of you may know, let's say the most interesting part of London, where all the tech industry is the east part, where there is also creative industry and tech industry, and specifically Hall Street area, and that's where all the big corps are. They have their London headquarters, and that's Hall Street. At the beginning was the first tech cluster in London, but now because it's a well-known tech cluster, it's very expensive. So all the startups, specifically the other startups especially, have moved a bit more down, like a bit more like Central East or Southeast. So areas like Hackney, if you know that, or Bethnal Green, are kind of becoming the more of a hub for the sort of maker moment, and also I know that quite a few other startups now have offices there. So that would be the Central East of London, and that's pretty much where all the interesting things are. And apart from that,
but tell us a bit about what are some of the interesting things that are happening there in a given month.
Yeah, so I mean there are a few events. There is the IoT meetup, there is us, and then there is let's say the interesting things are there are a few interesting startups now, because at the beginning there wasn't much at the beginning of the hardware moment here, there wasn't much big startups. There is no second generation startup that has done an exit in the hardware space. There is these rising startups now, which has, for instance, Rolly. I don't know if you're familiar, which is a keyboard, soft keyboard piano, and that one is the one that rise in the consumer hardware the most successful. Let's say Series A funding, and then there is Kano, the computer, if you know that. There is Cocoon, which is a headphones for sleeping. They rise to almost 2 million on Kickstarter. So there's quite a few Kickstarters, very successful Kickstarters like Cocoon, STHLMHW, which also raise money now, like I think pre-Series A. Primo, which recently did a Kickstarter for $1.5 million. There is technology will save us as well. So Extreme Flyers, which is the micro drone as well. So there are quite a few now. Like literally, these are the most of them that are kind of becoming successful is the last year, 1.5 years. They're very recent, and now it's starting to be more interesting also because initially you would have a difficulty to fundraise, and now instead it's also kind of growing the ecosystem around funding. So more angel investors will invest in hardware. Meanwhile, before no one. There are more VC that are from the software. Usually investing in software now. They're also investing in hardware. So like Button Capital and Index Venture have invested in Kano and Rolly, for instance. There is quite a few startups that come back and they have been incubating in the US or Axe in Shenzhen, like Cocoon, for instance, is been incubated in Axe, and so there is also like fortunately here the European led of Kickstarter and Indiegogo, which is also is also very useful because they will connect with the startups, so they will actually give a lot of help to them to help them to prepare their campaign.
And David, what are you doing with the Hardware Pioneers? What's that about?
Yeah, so initially we started as a hobby, and then last year in August we chose Fondai in a company because we wanted to do this full time because we really enjoyed that, and then we've seen that is a massive impact on the local ecosystem. Like the event that we do. And
what event is it? We don't know your event, so tell us about your event.
So the event is very similar to your event. I think it's a very similar format. We do like a 3 hours event more or less, and there will be about 200 people more, and we would invite influencers from London and from around the world when they pass by London, and hardware startups as well. We mostly do talks, like short talks with Q&A from the public, and then we have community announcements, so everyone at the event can actually stand up, go on the stage, and they have 2 minutes for giving a pitch, or for just if people are hiring or if they're looking for something in particular, fundraising, etc. And then we do some networking. It's very simple. And then after that we started the Hardware Academy at the end of last year, which is more like we partner with companies in the IoT and hardware space, so that we can do more educational content. So like people can try technologies. So for instance, the Intel head is on board, the Intel engineers would come, so that people can connect and can understand, can solve problems if they have some problems, for instance.
We'll definitely stay in touch about like how to learn from your experiences with Hardware Academy and Pioneers. For the people here, if they want to learn more about what you're doing with Pioneers or with the Academy, or just get in touch with you to get better engaged in London, how do people reach out to you, David?
Yeah, so you can. We have a website, hardwarepioneers.com. If you wanna have a deeper look to what we do, and hardwareacademy.io. Or otherwise, you can email me at david@hardwarestartup.io if you pass by London and you need some introduction, or happy to help.
I'll put up David's contact details on the lineup from for all. I'll put up the contact details for everybody in the lightning talks. Cool, David. That's unfortunately all we have time for. But thanks a lot for dialing in.
Thank you.
And have fun in London.
Thank you. Bye-bye, guys. Bye.
So that went surprisingly smoothly. Sorry, John. Right. Speaking of John, here we go. You're up next. Do you want this thing, or you want the other mic, or you want to try to? We kind of need to put a mic on you, either with this one or the one that goes on your face. Otherwise, we got nothing for the video.
I'll do face so I can use my hands.
Yep. Looks like. Are you gonna draw on the whiteboard? No. Okay, I see. Cool. Welcome, John. Not really, yeah.
Hello.
Yes.
Hello. Good. John Scholin, nice to meet you all. So I have type 1 diabetes, and I've had type 1 diabetes for about 30 years. For those of you that don't know, type 1 diabetes, you feel very crappy. In my instance, my parents recognized something wasn't right. Bring you to the hospital, and you're in the hospital for 1 or 2 or 3 days, and the doctors go, and they give you this incredibly powerful drug, and they send you home, and they say, figure it out. And of course, when you're living with diabetes, they say there's about 22 different factors that we're dealing with every single day in order to control our blood sugars and ensure that this drug that we're taking, insulin, which if you screw it up becomes fatal. So I come from software technology, but the problem I had taking insulin 4, 5, 6 times per day, every day, I would forget if I'd taken my dose. And I kept asking my doctors, why is there no solution to helping me remember if I had taken it or not? And they say, it's coming, it's coming, it's coming, it's coming. Never did. So we made this product. It's called TimeSlin. It's very simple. It's a piece of plastic. It has a clock in it. You replace the cap on your insulin pen, and it tells you when you last took your insulin. It's very simple. We sell it around the world. We have a couple 100,000 people using our product every day. The point for me is that when you're dealing with a complex disease like diabetes, if you can simplify one decision for those people, it can be very, very, very powerful. You can make people live a safer life, more balanced, and let you focus on other things other than your diabetes. So that's the product that we make and what we're doing. We make a piece of plastic with a clock. It's pretty simple, right? But of course, using data to make better decisions seems like it wouldn't be a revolution, but when you're dealing with healthcare and medical devices, it is. Most of the devices that we're still using, they look like Game Boys, and I'm not talking about the Game Boys that with, not even a color screen. I'm talking about the old school Game Boys that are terrible. Those are the devices that we're dealing with. So we've been trying to figure out how we can move from taking away this complexity to making simple products. So when you have diabetes, take a step back. My body doesn't produce insulin. So I need to regulate. The basics are how much I'm taking in terms of energy from food, et cetera, how much I'm exercising, what my blood sugar is. You try to balance all this stuff out and forget about the other 17 factors. So what I've built here, using some open source tools, is an artificial pancreas. And this is an artificial pancreas running on a raspberry. It uses this stick to communicate to this pump, and it communicates with this continuous blood sugar meter, which is attached to my arm. And I don't have any of the wires with, it's not running, and it doesn't have the big battery that I carry with. But this is not a very usable device to be carrying around. There's currently about 25, 30 people in the world that are running this thing. And it's been an interesting project to develop this. So why have I done it? I've done it so that I can start to figure out and see what are the possibilities when you're starting to get data about your body, your condition, your diabetes, and what can you do with it. And our idea has been to develop this product in a way so that you can start getting the data that's coming off this tremendously powerful drug and start doing something useful with it. So let's go back to sensors. We're here to talk about sensors. We believe we're one of the only companies, if not the only companies, that in an accurate way is able to determine how much insulin has been delivered in an insulin pen by figuring out where this plunger is. Now, okay, figuring out where a plunger is with a sensor, that can't be so hard, right? Well, we're talking hundreds and thousands of a millimeter in a way that has to be done over a huge series of time by myself, our parents, our kids, in a very, very, very regulated environment. So and it's not just a matter of taking a picture and figuring out where this thing is. The methods that we've developed are, we're figuring out if Newton's laws are correct when we're doing this stuff. So it's been an interesting journey. But in line with what I was meant to talk about, what we're trying to figure out is a piece of plastic with a clock. This is a pretty simple product. Now, how do we take all of these devices and start uncovering all of this data and being able to provide it back so that patients are able to benefit from it, healthcare providers are able to benefit from it, and payers are ultimately able to benefit from it. So I think, I think that we've cracked the code for how to do this now, and we're now working on using different kinds of sensors in our device together with exposing that data in a way which is relevant for a 3-year-old, a 35-year-old, a 40-year-old, an 80-year-old that's living with diabetes. So that's the stuff that we're working on. And I think the key concept that I wanted to bring is how important it is to not introduce more steps to people's lives, to complicate what they're doing, forcing them to learn about new error codes, trying to tell them is error 5 worse than error 7. That's what we're doing. Thank you.
Good job. Perfect on time. You were following the timer very closely, I could tell. Great, thanks a lot. We don't have time for questions and so on, but if you stay around and if you guys are interested, you can catch him afterwards. So I think, Stuart, you're up next. And I think I am, do you want this one, Stuart? Or can you take the mic?
Yeah, I'll take the mic. I'll take this.
You will take that, okay. And Stuart will talk about how to give your robot an imagination. I will do the time for you, and I will also be your PowerPoint clicker. Okay?
Can you hear me, everybody?
You're going to have to put this with you somewhere.
Can you hear me, everybody? Can you hear? Not yet. No, I did on the other ear. Right, okay, sorry about that. Yes? No? Hello? 1, 2, 1. Yeah? Okay. Can you hear me now? Right, okay. Good. Okay, how to give your robot imagination. I hate this picture. This is like one of the, they always look like that, but they never actually work like a human being. Next slide, please. Okay, so what is imagination? We're talking about imagination for robots. Imagination is the ability to form new images and sensations in the mind that are not perceived and through senses such as sight. That was good. Okay, next slide, please. So in a robot domain, robots have sensors rather than senses. They're not the same as human senses. Smell and taste are not usually found on a robot. Not even this robot, Big Dog, by the way. Next slide. Next slide. Okay, so the world view of a robot is very different to ours, very, very different. Robots detect many things human beings cannot detect, and this is the horrible live demo. I hope this is going to work now. Do you hear that? No? It did work. Okay, so basically this is a NFC tag. Now this you can use in a robot, but we can't pick it up when we do that. Next slide, please. So robots can have a lot more sensors than humans have senses. So this is actually a Raspberry Pi sense hat. It has 6 sensors built in. This is the one in the space station, by the way. I've got one here so I can show you afterwards, and it's even got like a mini joystick there. So it has 9 degrees of freedom, you know, accelerometer, et cetera, pressure, humidity, temperature. But we're not going to put it in your garden, so you're okay. Right, next slide, please. So it's different to human hardware and software. There we go. There's the phone. This is an old phone I use for demos. Sensor data from the real-world physical events is usually converted, analog to digital converted, to electronic digital information, sensor readings, and then it's processed with a digital computer, mobile phone, or whatever. Next slide. Okay, next. So, when did the sensors produce that data? You need a timestamp. That's really important. A lot of microcontrollers don't actually have a real-time clock, so they're not able to know exactly when something happened. So we need to stamp, okay, the events happen at that time, and you need to store that data. And as we've heard, it's a lot of data, and it's a real engineering challenge to make sense of all that. Okay, next slide. So the real world is not the internet. It's an open loop system. We're not going to be coupled to the internet if we're going to move around in the real world. Okay, next slide. So now we get down to the interesting stuff. How do you create an imagination? Techniques, please. So the simplest technique is you imagine a higher or lower sensor reading than you've previously got. So you take a reading and then you imagine, oh, I'm getting twice the normal rate or something that you've never actually had. Going for humidity, for example, if I've got high humidity, imagine your Raspberry Pi's been left in the rain, your humidity sensor might register that. If you get a very high reading, that's what happens when you put it in the rain or something. Okay, next slide. And now, Charlotte. This is true story. Charlotte, an old friend of mine, had synesthesia. She mixed smell and color, so she'd see something, and she'd go, oh, that's a purple smell. And this is known as synesthesia. She actually mixed up her senses. So she took in a nose, and then she saw color. Okay. And people can mix sound and color and get a blue note. This is quite common. And it's a bit like the old electronic sound to light in the 70s disco. You remember? I was there, you know. So this is an Atari one. Ah, I see you there. Okay, next, right. So what happens if computers mix sensor data? So you take in some data from one sensor and you imagine that it was through another sensor. The same idea as sound to light. So that's like synesthesia. That's like getting new information, a new scenario. Okay, next. So also you can detect patterns, sensor readings at this time. Is it one-off or is it every 5 seconds, every day or something like that? So you can see if there are sequences of events and then patterns can be detected. So that's another way. Can I actually think that that's going to happen next week or tomorrow or something? Okay, next one. So recurrence, events, sensor readings can repeat. Basically, we use learning sequences and patterns and help predict the future. So you actually can, in a concrete way, do something. Okay, next. So you can also have what's called sensor fusion. If you bring in more sensors at the same time that you've got these two sensors, you can put another one, and then you're processing several associated sensor data streams at the same time. And you can get a magnetometer and a camera readings to a temperature and a pressure sensor, humidity sensors. I'm going to show you a color camera afterwards if you want to see one. So when bad weather, you might even be able to detect with a magnetometer lightning flash, stuff like that. Next slide. Okay, so summary. Imagination techniques. You can simulate a value, you can process from one sensor as if it came from another, and you can just associate more sensors together, sensor fusion. And here are some examples. This is you can download all this, so you don't need to take pictures, it's all there. And I've got live links as well. Next. So that's it. So the conclusion, the robot takes real-world sensor readings in its own domain. Concepts are derived from these readings and sensor combinations, and these concepts are combined to form more complex terms. It needs a machine language to describe this, a new language. These concepts are modified values, and they're not taken from actual reasons, but imagined. So this is just the basics, as I said. It's a challenge in engineering, but with this, you could exchange information between systems. Okay, thanks. And thank you.
Very nice. Thank you,
Okay,
Stuart.
thank you. At the end, if you just switch. If you want to see this in hardware, I've got 2 slides. I've actually got where you can get the Raspberry Pi software for the hat, and also where you can get the camera that recognizes objects, which I have with me. I can show you afterwards.
Very
Thank
cool.
you.
Thank
very
you.
much. Thank you.
I'm going to take that part of it also. Okay. Thank you, Stuart. And Stefano? Yes, perfect. Do you want to try to find your deck? Here we go. This is what you want, right?
Yeah.
Was it? No? Yes, no?
Was not the presentation. Yeah, it's,
Oh, whoops. My bad.
I'm the guy with the text file, raw text file with NUR.
Isn't it this one?
Yeah, it looks like that.
Wasn't that one I just had up? No?
No. So
Okay.
that's weird. Can I sorry? Don't see the cursor.
No, you're on the other screen. Why don't we skip through to the next next one, and we'll just come back to you
Yes,
in a moment.
definitely.
Why don't we do
And,
that? Okay. We shall try something. We'll try something else. How about Åsa? You ready? Yes, okay. Very cool. So welcome Åsa to the stage instead.
Okay, so my name is Åsa, and I'm going to talk about, I think.
Oh my God.
Don't start the time yet, please. So I'm going to talk about my experience from taking some hardware startups and makers to Shenzhen, China. How many people have been in Shenzhen? A couple? Nice. So I'm going to talk about this in 300 seconds. So first, what is Makerresan? Thank you. And what did we learn? And then you'll get to experience some parts of Makerresan. So a few months ago, actually in March, we took a group of hardware startups and makers to Hong Kong and Shenzhen. And Shenzhen is also known as the Silicon Valley of hardware. I've spent a lot of time in Shenzhen before, prototyping and working with product planning. And when I got back to Sweden, I met quite a few hardware startups who were successfully funded on Kickstarter, but they didn't get to deliver their products. And the problem seemed to be related to Shenzhen and production. So I wondered why and how hard can it be to fix it? So our response to that was to create Makerresan. So we wanted to help startups and makers to turn your ideas into reality and get them on the market. So yeah, how can I skip here? Fast forward, we had a lot of fun. We met a lot of, for example, hacks and other entrepreneurs, and I'll be happy to talk more about it. But fast forward to what did we learn? So I think Shenzhen is the place for small batch manufacturing, and I would recommend anyone to go there and, for example, look for sensors or parts for your products. And there's a big ecosystem to connect with, which is becoming more and more accessible to people. Thank you. Also, prepare to spend time there. Get out on the factory floor. There's a lot of knowledge around production that can really make a big difference for your product. So prepare to spend time and work with them. The lead times are so much shorter. You can get a custom-made PCB made in something like 24 hours. So you can really kickstart your project. And also the maker movement here is usually maybe not for profit. In China, it's much more business oriented. So when you meet Chinese makers, they're mostly in it to create a successful startup and make money. And what are the synergies between Sweden and China? Sweden has been very good at design and innovation, and China is traditionally very good at production, but is also becoming more innovative. And I think there will be a lot of good synergies for Swedes to work together with China that would benefit both Swedes and Chinese people. And that brings me to number 3. You will get to experience some parts of Makeresan. How many of you know Simone Giertz, the queen of shitty robots? Now you will know her if you didn't. So we took her to the world's largest electronics market.
Hey, my name is Simone Giertz, and I am here at one of the world's biggest electronics market with Makeresan, and we're gonna check out some of the stuff that they're selling here. Okay, so at this market they have everything from very, very small surface mount components and also bigger products. And I think the bigger products are upstairs. So let's go and check that out. So these are probably some of the biggest LED lights I've ever seen. You can get my head for scale here. You just have one that just says random nice things here. Apparently it's my birthday today too. This is crazy. Have you seen how cheap these are? They're 920 kwai. I don't know what that's in dollars. It's less than $900. But I've heard that they can explode, so I'm not sure that I want to buy one. But I wonder if I can try it. No. Okay. I think I just asked if I could taste it, but she understood what I said. She just told me I was really good. I felt like maybe overestimated my ability. So we just entered an LED forest, and it feels kind of trippy. I don't know. It's very pretty. Whoop. Now that trip's over. It's for free. So now we've left the main street and we're in kind of the smaller streets. And I've heard, I don't know if this is true, but I heard that they send about 500,000 packages from this market every day. That's crazy. I don't know what I'm doing. It's a pretty good feeling.
他以前是用松下的，现在是用国产的嘛。他说现在瞬间我们专门是有。
We've been here for a couple of hours now, and I feel so tired. I feel like a zombie. I think if you ever go here, it's probably good to have a shopping list because all I bought were these 3 for 1 kwai. I don't know. But still, it was a pretty good experience. This is just super cool. And they have basically everything.
Yeah. So hope to see you in Shenzhen, and if you have any questions around production or anything related to China, ask me.
You ready, Charles? Yes. Okay, so you wanted the deck that I just had on screen, didn't you? So that's right. Okay. You'll take the mic.
Yes. Hi there. Yeah, that's it. There we go. So this is Lumu, and I'm Charles, and I'm going to present you my current state of my master's degree project at KTH, which is an attempt of trying to show how technology works for people that don't have a clue about it. So it's about Lumoino, which is basically the talking light. Lumu, Lumo can talk quite a lot if you wanted to. And it's a toolkit actually. Lumoino is a toolkit for prototyping, for people, for visible light communication, and for people that are makers and interaction designers like me. And you might think, so what are you talking about? And I think some of you heard about the topic Li-Fi, communication through light, like Wi-Fi, but through light. And actually, in my case, it's just infrared, but you see it. And the project is in the very early stage, and I need to speed up. It's a toolkit that you get a feeling for how visible light communication works. And with simple examples and experiments, you can try out and figure it out with Arduino and stuff, how it could work. And also, on top of that, you build basically your own prototypes. Again, it's based on Arduino. It's based on little bits as well. And my goal was to follow the Maker's Manifest, which is cheap components, simple components, and everything open source. And simple code examples, very important because you don't want to mess yourself up in code. And soon to be completed, hopefully, on GitHub. And here are a few examples, which is, I can explain it all later if you have time. I have a few examples here, but it's like a toolkit where you basically try out what are the material aspects of visible light communication. So what means speed or distance and optics. This is a nice picture of how the light actually talks to the sensor, which if you want to say, you can like literally translate it. It's like digital communication, but you can see it, and also you can hear it. And a little example how it works. This is based on little bits. So these two bits, the one with this one here, and the top one, they're sending data to each other. And if I break the circle, it stops. There's not like much magic to it, but the magic is that you see actually light, and light that is communicating with the other device. Yeah, that is actually what I wanted to tell you. Please have a look at GitHub, and if you have questions, I'm here.
Good job, Charles. Okay, here we go. Did I see Björn just arrive? Nope, 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 nope. Damn. So Björn was going to talk a bit about the prototype center, which is actually around the corner. Maybe he's downstairs. If he's back in a moment, we'll put him back on. If not, then maybe next time. Meanwhile, let's come back to you in a moment. We'll need to get like the file that you have. We need to get it like out of email and get it over in some other format. So maybe we can fix that over there. Yeah, that'd be great. And then the next to last is actually not Pontus. I think this is a picture of Pontus from Hyper Island. So he's not going to do the presentation, but it is a presentation from a group of Hyper Island students that has just done a hardware project. So welcome.
Thank you. Hey, I'm Wesley. This is David and Teresa, and we also have two other team members that couldn't be here with us today. And let's just get the slides up. Yeah. So we had a client, STHLMHW. I guess most of you know who STHLMHW is, and most of you must know Konken, which is a really popular product here in Sweden, but also worldwide. Let's go back to 1978 when Konken came to life as a product due to small children developing back problems in school. So this beautiful Swede, tall, blonde man designed this backpack for the children. And come September 2016, we'll see the launch of Rekonken, which is a backpack produced out of 95% recycled materials. It requires 75% less in water production. And just to paint you a picture, is made out of 11 plastic bottles. So going back, we started ideating, prototyping, and we wanted to go back to Åke Nordin's vision, which was to improve back posture. So we merged existing technologies with the Rekonken, which David will demonstrate to you.
So yeah, we just the first prototype that we made is just a measuring tilt. So we use gyro and accelerometer. You want the sensor fusion magic. So this is what we came up with in 2 days. And yeah, you have a gyro and an accelerometer, and it's calibrated to my good posture right now. So my bad posture is this, if you see. Yeah, that's basically it. And I guess the next version would be to use a proximity sensor as well to only trigger the vibrator motor that we have on the back, only when you're wearing it and not all the time. And of course, you want to sample the data and not trigger it, just as it tilts, and to only trigger it when you have a bad posture for a sustained amount of time. That's it. And we have a little video to show the app. Are we going to see that? Yeah.
We just need to drag it to the other side.
Oh, okay. Wait. Which side? This side?
The other side.
The other side.
Yep, that's right.
I'm trying to. Make it big.
Cool, that's about it. That's us. Thank you.
Good stuff. Thanks a lot. And then I think we are on to our last talk. Let's see if we can get this thing rolling. Yes. Perfect. Yes. Plug that in. So we're back to my previously failed attempt for software best practices. And we are going to old school with the USB stick. So let's hope that works out.
Just as in work.
Cool. And I think that's it. Are you going to come on and play guitar? That's very nice. Do you want to just come up and say something about the guitar since you're standing there with it and we're waiting for the presentation? At the same time,
I
okay.
just can't get Safari. Where's Safari?
Okay.
Fantastic. Yeah. Finally. Okay. Thank you so much. Great to be here. So I'm Stefano, and Luca here. If you want to come and show the guitar. So we are from Mind Music Labs. We are actually sitting downstairs, a couple of floors. And pardon me if I talk about software at Hardware Talk. And how do I? It's a presentation here, right? Present. Yeah. Yes. Great. So what we have is this guitar that now 1 minute is too short to show it live, but if you play the guitar, you can try it later. So just a very quick video about what the guitar can do. It's as an integrated sound engine.
This is the demo video for the first prototype.
And so it produces sound from the wooden body. And we control sound with sensors. Okay. But the guitar was pretty much an excuse because I would like to talk about this physical computing. So we do use some kind of special sensors for capturing the sound of the strings with kind of special pickups. But I guess that not many of you are interested in that. So what might be interesting to anyone is that musical instruments, they pose some kind of requirements when you want to do interactive devices, like physical computing. So other examples of these kind of devices are like stuff that does augmented virtual reality, tangible interfaces. So basically, there are just tiny little things that they have electronic inside, but you feel like they are magic. So the electronics, the computing disappear. And how you do that? And it's mostly you have to design the thing so that you bridge, you eliminate all these gaps between the perception and the action. So it comes down to just 3 factors. It's time, scale, and psychology. Yes, it's the first one, the last one, yes, it's really psychology. Or maybe better talk about psychophysics. And actually, Luca here is our expert in that. He has a PhD in psychophysics and audio tactile perception. And the critical thing is that if you compare to how sensors are used like in a nuclear plant, in a normal control loop, you have a closed loop interaction from sensors, computing, and actuators. And for these devices, you have the human in the middle. So what is important is not to have sensors that are precise, but they have to feel precise. So at the end, it's just a human judgment. And about time, you need to achieve these good results. And mostly it comes to 2 factors. The first one, you need accurate timing. So if you press one button, one pressure sensor on the guitar, and if you have to wait 10 seconds and then the sound arrives, you break the magic. So you need to treat sensors and sample the signals like you would do with proper signal processing techniques. And for the rest, it's really a lot about latency, which is the most critical factors. And talking about latency, it depends on your target product. You may have different requirements on your target number of the latency that you have to achieve. For example, for pro audio processing, we have to stay below 3 milliseconds round trip. And if you just consider the time from action to sound generation can be 10 milliseconds. If you do not a pro, you buy consumer product, this you can stay 30 milliseconds. Or if you just need the normal stuff like user interface, you can go up to 100. And so these are what you have to achieve, and then you have your constraints. So I don't tell you to do everything bare metal, because a lot of stuff, especially if you want to communicate with other computers, you need to use more higher level stuff, computing stuff. But the important thing is know where the latencies come in your chain. And this is a table, a pretty famous table, these latency numbers every programmer should know. And just be careful that usually those are average latency times, but what are important are the worst case. So there's just be careful to take the worst situation into account. And about scale, scale means that you want a natural linear feeling of the sensor. So you want to map the sensor, let's say, from 0 to 100 in a scale that is perceptually meaningful, so that the pressure feels lean. How you do that? You don't do it in an engineering way. You let some guy like Luca to tune the parameters, so you don't need to have any compile time constants. Because if he has to wait while you compile, you flash the board, and he tries again, then he's not able to tell which one is good. So every parameter has to be tunable in real time. And that's pretty much where the secrets. Thank you.
Okay, so that was everything. How do you feel? Tired, excited, great. Yeah, so let's give all the speakers a hand. So that's all that we have for tonight. Thanks a lot for coming. Next time is Tuesday, 14th of June. So hope to see at least some of you guys again, and please spread the word. And as we talked about earlier, if you can share on social media, that's good for us. It helps us with our sponsors. And last request, if the speakers could maybe stay on for another 5 minutes so we could do a group photo. We haven't done that before, but that would be great. So thanks a lot, and see you next time. So, speakers, if you could come up here for a sec. Speakers. There. Okay, who's going to take the photo? Can I ask you one more thing? Since you're you're on such a roll. Okay, up on this, what are we doing? I guess we can just stand here in front of the stage. Yeah, I guess. That's probably not the best idea. What are we going to do here? I guess we can just have some people stand up here and some people down there. Okay, more? Do we have more? More speakers? Yeah. Should we kill the projector? Yeah. Why don't we do that? Is that better? Yeah, okay. That's good call. Ellen, why don't you come up? And do we have any more? No, that was it for speakers, right? Yes. Awesome. Yeah, take a few. And thanks everybody for coming. Thank you. Or if we have video archive. I was thinking about it. What do you think about it? Do you want to come back? Very nice. I've been looking at Did you talk already or know about how it runs the yeah, you should maybe put one, maybe you could put in touch with a really nice guy, or he's very involved. He'll start to check on it. So I'm sure he would be able to give you suggestions. Very good.